Our next collection type is a hash set, not a hash map. And a hash set is, if you look at the declaration here, it is a hash map where the value is empty tuple. So it's a hash map where you don't care about the value, you only care about the keys. And you can also look at the source here again. Here is a hash map, and then here's hash set, and you can see they're very similar. So a hash map has a K, V, and this S thing. You can ignore that for now. Whereas this only has this one generic type, and then it has a the random state that we're not going to think about yet. But you can see it has one fewer type. So 1, 2, and then here it's got 3, and it's only returning keys and values in a hash map, whereas a hash set is T. So it's just one just returns the keys, and that is useful if you want to know did something appear or not, and you don't care about a value that matches it. So they are, of course, in the same spot, standard collections hash set, and I'll show you an example where you would use a hash set. So we are going to bring in a whole bunch of numbers. So we call this many numbers vec, and we pretend these are random numbers from 0 to 100, and we want to know, did we see the number 8? Did we see the number 7? Which numbers did we see and which ones are not in there? So we are going to use a hash set to do that. So we will say number hash set is equal to hash set new, like that. And then we'll say for number in many numbers. So the vec up here on top, and then we're going to say number hash set. And it's the same method. You have insert, which is just a basic insert the number. So it's going to have all the numbers that exist here, and then let's say we want to see how many numbers are in there and how many numbers are not. So hash set length, and we'll say number dot or number hash set dot length. So how many items are in there? Let's say if we have 50 items there, then it means that we got 50 numbers, and 50 numbers are not there. And then we'll say we'll print this out and say there are something numbers, so we are missing so and so. Then we'll have a hash set length, and because these numbers are 1 to 100, you do 100 minus hash set length. So if there are 90 unique numbers, then it'll say we are missing 10. And then the next line, let's also print out the numbers that we're missing. So mute missing vec, and then we'll just make this a vec of something, and then we'll put them into here for number in 0 to 100. Actually, we're going to say that these are numbers from 0 to 99. If let's say number hash set, and then we're going to use get, which returns an option and needs a reference to look it up. So we'll take reference to number. If it is none, then we will push the number into our missing vec. So let's say if it goes through these numbers and it looks for 5 and it gives us none, then we will put the number 5 into missing vec so that we know which numbers we are missing. And then down here on the bottom, we can, let's say we will not have a print line, we'll have a print and does not contain, let's see, and then we will do that. And then we'll say for number in missing vec, and then we will print the number with a space instead of a new line. So let's see if everything worked. And yeah, it does work. So you can see there are 66 unique numbers. So we're missing 34, and then it says then it pushed all of these numbers into missing vec because it returned a none to us, and that let us see all the numbers that are not in there. And one other thing to know about a hash set is that you have a hash map and a B-tree map, and they're very similar. And you can also have a BTreeSet, and that is also super easy to do. If you have a hash set, then you just change it to a BTreeSet. Let's see, over here we need a BTreeSet new. BTreeSet new, and then the difference is obviously going to be that a BTreeSet will let you give the numbers in order, and so we'll let's say let mute number BTreeSet this time. Wait, what are we doing? BTreeSet new. Shouldn't have deleted that. But it's back. Okay, for number in many numbers, and then we are going to insert the number BTreeSet dot insert. Put the number in there, and so we put them all in, and we only have the unique numbers, of course. And then for entry in number BTreeSet, and we're going to print them out, and you can see that they will be in order because it is a BTreeSet, and that can be useful sometimes. And of course, a BTreeSet is I think it's a little bit slower than a hash map, which is why you don't always want to use a BTreeSet. But it has that that function that can be useful sometimes if you need it in order. So there you go, 0, 3, 5, 8, and so it's going in sequential order, even though we put the numbers here in a completely random order. And besides that, it's very, very similar, and all you have to do is change HashSet to BTreeSet a lot of the time, and the methods are very, very similar.